Meet phi, about 1.618. Greeks called it the extreme and mean ratio. Renaissance artists called it divine proportion. Today it is the golden ratio. It shows up in pentagons, star diagrams, and certain rectangles, not because someone sprinkled magic dust, but because of a precise geometric rule. What is that rule, and why is phi the only number that satisfies it? A common guess. Phi is everywhere because humans find it beautiful, so we keep drawing it on purpose. The math says something stricter. Phi is the positive solution to a ratio equation forced by geometry. When a segment is cut, so the whole relates to the large part exactly as the large part relates to the small. That equation has one special number. Beauty debates come later. Cut a segment into two parts, a longer piece A and a shorter piece B. Demand that the whole A plus B compares to A the same way it compares to B. Write that as a fraction equation. Cross-multiply, and you get a quadratic. One positive root is phi. The ratio is not chosen by taste. It is the number that makes self-similar splitting exact. Build a rectangle whose sides are in ratio phi to 1. Now cut off a square from one end. The leftover rectangle is smaller, but it has the same proportions as the original. Cut again. Same shape again. Every slice produces a miniature copy. That self-similarity is the golden rectangle's signature. No other ratio recycles itself this way. Euclid's world built shapes with compass and straightedge alone. You can construct phi without measuring. Draw a unit square. Bisect the base. Swing an arc from the midpoint to the top corner. That diagonal length, added to half the base, builds the golden ratio. The construction is ancient, checkable, and independent of any designer's opinion. Draw a regular pentagon. 5 equal sides, 5 equal angles. Connect diagonals, and they cross in golden ratios. The diagonal divided by a side equals phi. Side by side, pentagons pack phi into their bones. This is why five-fold symmetry and the golden ratio travel together. Not coincidence. Triangle similarity inside the star forces the same equation again. Could some other ratio self-replicate in a rectangle? The equation says no. The quadratic has two roots, one negative, one phi. Only the positive root measures a length. Phi is irrational. Its decimal never repeats. Yet it is exactly the root of a simple integer quadratic. Uniqueness is the point. Geometry leaves no room for a runner-up. You may have heard phi linked to Fibonacci fractions. That is a different story, one we already told when spirals and sunflowers were the topic. Here the focus is pure shape, pentagons, rectangles, and compass arcs. Fibonacci ratios only approach phi far down the sequence. Geometry hits phi exactly on the first cut, with no seeds or shells required. Here is the surprise. Phi looks like a picture ratio, but it behaves like a number with a personality. Multiply phi by itself, and you get phi plus 1. Divide 1 by phi, and you get phi minus 1. The geometry creates an equation. The equation creates a number that keeps regenerating itself. That is why phi keeps resurfacing, not in every logo, but wherever the same cut repeats. Regular pentagons and decagons use phi in their edge-to-diagonal ratios. Icosahedron geometry, 20 triangular faces, encodes phi in its measurements. Architects and typographers sometimes use golden rectangles as a proportion guide, but the math claim is narrower. Phi is forced where five-fold symmetry and self-similar rectangles meet. Spot the construction, not the branding. Recap. Phi is the positive solution to a ratio equation. Whole to large equals large to small. Golden rectangles shed squares and stay the same shape. Compass construction finds phi without measuring. Pentagons trap phi in their diagonals. The number is unique, irrational, and self-referential. It appears in geometry because the diagram demands it, not because every rectangle claims to be golden. Phi is what happens when a shape insists on copying itself. Next time on Math Sketch, why squaring the circle was impossible and what compass and straightedge limits really mean. Subscribe for weekly pattern hunts. This is Math Sketch.